Yeah. Hi everyone. I welcome you all to the first module of this week, which is Foundation of Data Visualization. So before we start working with tools like Plotly and Power BI and Flourish, we need to understand why visualization matters and what makes one effective, right? See, visualization is not just a decoration. It's a way of thinking with data, revealing patterns, stories the number alone cannot express, right? What I would suggest you is that before making any graph, you should have few questions in your mind, like what does my data show? What target do I wish to achieve for forming EDA? Okay, and who are my audience? Is there any pre-processing required or not? Okay, so all these questions, if you have the answer of this question, no, then you will be able to think about the right graph. Okay, which visualization you should use, right? Yeah. So yeah, the goal for this week will be just to set the context and importance of visualization before diving into the tools. Okay, so here if you see the first question is what makes the visualization effective, right? So see, a good visualization simply answers a clear question. Okay, and it tells you a story, not just to display a data. Okay, and also it's accurate, that is it always stays honest to the data. I mean whatever fact is there, real fact is there, it tries to convey that only. I mean it does not mislead to people to conclude something else, right? So just some simple suggestions here. What I would say is that see, there are many common mistakes people do, like whenever you are going to make any graph or anything, no, try to keep it as simple as you can, right? No need to overload it with colors, use I mean do not use unnecessary 3D effect. Okay, and most important thing, like which I see many times, people avoid or people ignore scales and context also. Okay, do not do that. Okay, and so yeah, overall I would suggest you avoid cluttering the graph. Okay, so this is one of the graph where you can see, I mean, this is a simple bar graph. Okay, here if you see, people have the person has converted into a 3D, and see lot of redundancy is there. In technical term, we call it as a chart junk. Here, if you see, all the red lines is representing the things like which is not at all necessary. I mean, which is there in the graph, but it is not conveying any information, right? So yeah, that's where redundancy is coming. Only these green lines are representing something which is giving you the information. Okay, yeah. So always try to avoid that. Okay. I mean, in case if you are using 3D graph, it means that there should be some extra dimension, or I mean, whatever things you have used in your graph, no, that should provide some information. It should not be like, I mean, just some redundant thing you have added in it, right? See one more example here. I have just compared 3D and 2D graphs. Here, this 3D graphs, I mean, it's tough to compare one with another. Okay, I mean, it's tough to get the idea. Okay, like how bigger or how smaller is one with another one. Okay, another bar. But here, I mean, in this 2D, it's easy to understand that. Okay, I've just taken different graphs for sample. I mean, it's not in the same range or exact same graph, 3D and 2D version of the same graph. I just take this some 3D and 2D graph for the demonstration. That's it. Okay. So do not try to think that okay, whether the two graphs are related or not. Okay, I mean it is not at all related, but I just kept it for the reference. Okay. See one more example I'll discuss here. See, I mean, what do you understand from this graph? Okay. So this is also, I mean, see, this is also one of the example of chart junk, I would say. Here, I mean, if you see this graph, I'll okay, take some time to understand it, like what this graph is exactly trying to show here. Okay, and then I'll also explain you. Okay, see, okay, I'll just explain you like what is happening in this graph. See, this graph has four parts about US metal used in 2006. If you see this left bar chart, no, this shows how much of each metal an average person used that year, right? Okay, and then this one, this middle circular one, this chart shows how many years the metal supply would last at the current use rate and at half that rate, right? And then this donut charts on the right shows what percentage of each metal came from recycling. Okay, and this bottom pictogram compares the US population to the world population. Okay, so yeah, I mean, see, however, the see, I mean, it is conveying, keeping a lot of information in a single graph, but at the same time, it's cluttered. I mean, it may look beautiful. Actually, it is looking beautiful, but it is cluttered. Here, if you see, the design has too many colors, lines, and a decorative effect, right? That is what is making it harder to read. The background pattern you see, okay, and icons, okay, so many icons. It is no, I mean, if you see, these are the thing like which is distracting you or us from the actual data, right? And because of this, I mean, our more focus is not on the exact data, it is on these icons, right? But ideally our most focus should be on the information which it is conveying, right? So this is what I am trying to say. So okay, and okay, so what is happening is that, I mean, broadly I have uh, grouped the different tools into three levels here. Okay, static versus interactive versus storytelling visuals. So you have already learned Matplotlib, so which is a static tool. Okay, and then we will talk about some so in this week, basically we are going to talk some interactive tool and some tool like which will help you to for storytelling. Right. So yeah, that is there. Okay. See, I mean, each tool serves a different purpose depending on your audience and medium, right? Yeah. So let's talk about grammar of graphics. See, the backbone of this entire week is the grammar of graphics. It's the philosophy behind tools like ggplot, plotly, express, and even how Power BI structures charts internally. See, the grammar says that every visual is built from layers, data, then mapping, okay, then geometry and design choices, okay, all these things, right? So once you understand that structure, creating a chart becomes like assembling sentences. You can express anything you want, right? So every visualization, no matter the tool, follows some structures, right? So here if you see, basically it has 7 components. So first component is data. So this is something like what you are trying to show. So what I would suggest you is always start with the data. Okay, identify the dimension you want to utilize, visualize, right? For example, if you are going to show yeah, 3 or 4 columns, okay, or 3 or 4, I mean, dimensions. So you have to go for 3 dimension, 4 dimension, okay, whatever. Just first decide that, then go for aesthetics. So it simply shows that how data maps to visuals like x-axis, y-axis, okay, or color or size. See, first confirm the I mean, yeah, second step should be to confirm the axis based on the data dimensions, okay, position of various data points in the plot. Also check if any form of encoding is required here or not, like size, shape, color, whether this should carry some extra information or not, okay. So yeah, that is there. And then you have to see scale. See, scale basically shows like how value translate to position or color. Okay. So what you have to decide here is that, so do we need to scale the potential values? If yes, use a specific scale to represent multiple values. Okay, or multiple or a range. Okay, what you are going to do, decide that. Then your next step should be about geometry. So geometry is something, the shape which is representing the data, such as bars, points, lines. Okay, this is popularly known as geomes. Okay, and this would cover the way we are going to depict data points on the visualization. Okay, so then comes the stats. So yeah, here what you have to decide, that do we need to show some statistical measures in the visualization, like measure of central tendency, spread, confidence interval and all, or not. Okay, and then comes the facet. So basically breaking facet is nothing but breaking data into small multiples. So you have to decide, do we need to create subplot based on a specific data dimensions or not. Okay, and then comes coordinates. So see, I mean, it simply says that what kind of coordinate system should be this visualization use. I mean, whether it should be Cartesian or polar, right? So yeah, that's how you can decide. So these are the layer of graphic. Yeah, these are the layer of grammar of graphics. Okay, and based on that, you can decide. Okay, I mean, which particular graph and how you have to plot. Okay, or I mean, in simple word, I can say that this grammar lets you build visual systematically, not just by guessing chart type, but by defining these layers, right? So yeah, let's do a quick comparison between Plotly, Power BI, Flurries, okay, and Matplotlib. Okay, I mean this is AI generated image, so that's why it has written Matplotlib like that. Okay, yeah. Anyways, before we end today, let's quickly compare the three tools we'll explore this week. We will first talk about yeah, Plotly, then Power BI, then Flurries, and Matplotlib, which we have already learned. Okay, so if you see the Matplotlib, this is a foundational plotting. This is used for foundational plotting in Python. Okay, and it is a code based. Okay, uh, and yeah, for this you need basic Python, right? And then comes Plotly. It's a interactive visualization. I mean, you see the here we I mean, it's like, I mean, we just add interactivity feature in the those graphs. Okay, this is also code based, and yeah, you need a basic Python knowledge. Okay, so yeah, that is there. And then you have Power BI. This is typically used for business dashboard, or I mean, you can say dashboard, and it is a drag and drop type tool. So where you can drag and drop different graphs and all. Okay, so people use it to create report and dashboards. Okay, and then we have Flurries, which is used which is used for storytelling and publishing. You can say this is a template based tool. Okay, think of them as a progression. Here Matplotlib gives full control for static visuals, then Plotly brings interactivity, then Power BI integrate data pipeline and dashboards, and Flurries focus on storytelling and presentation, right? So yeah, so what I would suggest you is that, I mean, after this session, just go and see few graphs, okay, available in the internet, or I mean, and try to provide some critic in this. What I mean to say is that, just see the graph, see what is good thing, first of all, yeah, what this graph is really trying to say. Okay, and then who will be the audience, what are the good things about this graph, is there any redundancy in the graphs, like, and what are the bad things about the graph. Just try to compare that. Okay, that will give you a good idea. Okay, and I mean, so if you judge such things, no, I mean, you will have that, like, what you do not need to do in the graph you are going to plot in the future. Okay, so yeah, let's wrap up this session. So in this session, we explore why visualization matters, how to judge its quality, and how every chart follows a shared structure. You also saw how Matplotlib, Plotly, Power BI, and Flourish fit into this larger picture of data visualization. Okay, so as we are wrapping this up, keep in mind, visualization is not about putting some good color and aesthetics. Okay, it is all about clarity, not complexity. Okay, see, a strong chart always has purpose, structure, and a story to tell. The tools may differ, but the goal is the same: help data speak in a way that anyone can understand. Okay, so in the next video we'll move from concept to practice, and we'll use Plotly for data visualization. Okay, yeah, thank you everyone.